Chess has been called the game of kings. It stood the test of time. It's been a bulwark of game theory. And we teach it to our kids, right? Hoping that the grit that they get from that sustained effort of using their intellect, participating in this game will be a positive part of their lives. We teach it to ourselves, thinking that it encapsulates intellect of pure reasoning. Kubernetes is a jewel of technical operations. A problem space that we as technologists have been struggling with for a long time, and turned it into a simpler problem, or a problem that can be grappled by teams.
The main benefit of Kubernetes is that it lets you take a whole bunch of different hardware, a whole bunch of different servers that you have available, or even a single server, and then you can give that server a template, right? This is just a laundry list of what you want to exist, and it will create it in a consistent fashion using the hardware that you've provided, even if that hardware is really different, or even if you need 10 of those things or 100 of those things. You give it the template that it needs to provide, and it will build it out. What's important also is that it will build out changes to that template. If I were to come to that template and increase it, or to change it slightly, it could build the exact repeatable artifact with just those changes that I wanted, and reason about how those changes get applied.
But could we combine them together? What would we learn if we took Kubernetes and we combined it and we bridged Kubernetes and chess? What would we learn along the way? What challenges would we face? And how hard would it be? If you like our content and want to see more, please like and subscribe, and we'll make sure that we keep it coming. And I'm going to need more ideas. So if you can think of other terrible technologies to glue together, or things you'd like to see me struggle through, throw those in the comments and I'll read them all. And I want to thank boot.dev. If you're interested in learning to code, then boot.dev is one of the best communities in which you can do it. Learning to code there and from people that are passionate about it and are willing to have some fun along the way. Check it out. And let's combine chess and Kubernetes.
So there's 4 things we're going to make Kubernetes aware of. The first is the pieces themselves, like the rook and the bishop and the king and all the actual pieces that make up chess. And we're going to give Kubernetes CRDs, or custom resource definitions, that tell it how to interact with it. What information do we need to store, and what board does it relate to, and how does that kind of process? We've got to build the board object itself. What pieces belong with which game, and how do we track that active state as it's going along? And then we need to visualize the thing, right? It doesn't make much sense, or it's not particularly enticing to look at this thing in the command line perpetually. And so having an actual way for us to see the chess game is going to be important to us. And then I thought it'd be fun to grab a chess engine and apply it to this. This isn't like an AI, like an OpenAI or a Claude or something like this. This is a chess engine where it has been pre-programmed to analyze chess positions and provide the best possible outcome, and to weigh how much of that's worth.
So it turns out it was a little painful, but let's take a look. All right, so I can show everything in Kubernetes. We've got resources and we can list these things, we can modify them, but we have no way of controlling the game, right? I need to know, hey, did I make a move that's legal? Did the game change, right? Are the positions different? Does a piece need to be removed? And some of those aspects that are important. How do we do that? And the answer is with a controller. Let's talk through a controller.
Easiest way to think about a controller or a control loop is to think about a thermometer. A thermometer, right, that's setting the heat in your house or your apartment, has an input. It has some way of reading the temperature that's out there. And it reads this thing over and over again. And then it also has a connection into a heater, right? Something that it can call to change the temperature in the room, or an air conditioner. And what it does is it takes that input, it says, hey, if it's cold, I need to fire the heater. And if it's not cold, I don't need to do anything. And it repeats the cycle over and over and over again. And that's what we're going to do for Kubernetes. We're going to build a controller that is constantly checking all the chess resources and making sure that they're doing what they're supposed to be doing. And I think this would be way more interesting to look at if we put it all together. So let's take our control loop and let's take the visualization and let's take the game state. Let's see what it looks like when we put it together. And it's working. You can see here that we can fork, we can do checks, we can do checkmates, we can do en passant, right? We can do lots of different chess things, and our Kubernetes state matches with our resources, right? If we make a change on the Kubernetes side, the visualization catches up. If we make a change on the client side, the Kubernetes side and the visualization update from that side as well too. But it's getting tiring doing all these moves myself. So I remade a game that you can literally do with blocks of wood, right? And probably do a better job, or certainly a less buggy job, but can your blocks of wood play itself? So that's the video. Like and subscribe if you want to see more. Give me some more crazy ideas and keep building things. You'll learn stuff.